Who discovered physics? And was it discovered or invented? Should it be split into its constituent parts? Let's take a look at some of the people who've contributed most to the field and why they're all interconnected. In this video, I'll attempt to run through the highlights of the different fields of physics and some of the history of how they came about. I'll cover a few topics, and I'm sure there'll be a ton I can't get to in this short video. Physics is the broadest of all of the scientific disciplines. Principally, physics is a hard science, meaning any of its theories are natural law and never suspended anywhere in the known universe. It's the script that all matter and energy must follow. In this video, we'll discuss a few of the key people that have discovered just a small piece of that nature and what their discoveries mean to the field. Isaac Newton. It's quite difficult to determine when the study of physics really begins. There were existing theories of motion certainly, most notably by Galileo, whose work on velocity, acceleration, and the beginning understandings of gravity heavily influenced Isaac Newton, born almost a year after Galileo's death, in 1643 in Lincolnshire, England. However, none of these existing theories were as perfect in their descriptions of the motion of almost all objects visible to the naked eye, and of distant objects yet to be seen, until Isaac Newton published his Principia Mathematica in 1687. In this work, Newton writes the script of not only the heavenly bodies, but less heavenly ones as well. Today we call this field classical mechanics. It's the physics of balls, springs, planets, almost anything you can pick up and touch or look at through a telescope. Now in 1687, with much of motion essentially perfected in mathematical form, the empires which were quick to adopt these theories became the masters of war of their time. Isaac Newton therefore indirectly played a large part in the success of the British Empire and its conquests. They could now much more accurately fire cannons from their ships on the seas and mortar fire on land, winning them a tremendous amount of battles relative to nations which hadn't yet adopted these theories. Newton is also famous for discovering the visible portion of the electromagnetic spectrum, by splitting white light into its 6 constituent colors. Newton famously distinguished between indigo and violet, so there would be 7 colors, a popular number among Masons of the time who believed the number 7 had mystical significance. Newton also published a work called Optics in 1704, where he postulates that a light beam is made up of a stream of particles, a generally accepted theory at the time, but we'll come back to this later. Covering Newton's contributions to physics beyond quite literally inventing the field, because in his day he would call himself a natural philosopher, would take me many hours, and we have quite a few more physicists to get to. Newton died on March 31st, 1727, in London. Michael Faraday. Michael Faraday is most famous for experimentally determining the first theories on electricity and magnetism. Faraday was born into a poor family in London on September 22, 1791, and never received formal mathematical training. At age 14, he started an apprenticeship with a bookbinder in London. He would spend the next 7 years reading book after book about subjects ranging from theology and philosophy to chemistry, when he was particularly inspired by the book Conversations on Chemistry by Jane Marcet. Faraday discovered the process of electrolysis, the electromagnetic forces, and my personal favorite, the inverse relationship between a motor and a generator. In 1821, Faraday realized that if he placed a magnet into a pool of mercury and hung a wire above with an electric current running through it, the wire would rotate. This was the world's first electric motor. And 10 years later, in 1831, Faraday would realize that the opposite effect is possible too. By spinning a disc through a horseshoe-shaped magnet, Faraday found that an electric current was produced by the motion of the disc through the magnetic field. This was the world's first electric generator. Now we come to the math guy in the equation. You'll find if you study the work and lives of physicists that there's often a math guy that directly complements and unscrambles the work of the physicist. Faraday is no exception. In fact, he may be the embodiment of the rule, since, like we said, he really only knew up to very basic trigonometry and really very little algebra as well. Enter James Clerk Maxwell. Maxwell was a Scot. Born in Edinburgh, he published his dynamical theory of the electromagnetic field in 1865, essentially mathifying everything that Faraday had determined experimentally. Physics and math go hand in hand, and without the rigor of mathematicians, physicists would have very incomplete theories. Maxwell was an integral piece, no pun intended, of this puzzle because he wrote Faraday's ideas down in the language of the universe, calculus. Maxwell said of Faraday, when describing his use of lines of electromagnetic force, that Faraday was clearly, quote, to have been in reality a mathematician of a very high order, one from whom the mathematicians of the future may derive valuable and fertile methods. Faraday is another titan whose work I can't possibly fully cover in this video. Michael Faraday died August 25th, 1867, aged 75 in Middlesex, England. Now we're really only covering the big players here, but a comprehensive physics history intro video would not be successful if it didn't mention Thomas Young. As a mechanical engineer, I can tell you that this man has contributed an immense amount to engineering, which is really just an application of physics. But he also conducted one of the most explored experiments in the history of the field, the double slit experiment. Thomas Young lived from June 13, 1773 to May 10, 1829, mainly in England. Around the year 1800, Young conducted an experiment whereby sunlight is reflected using a steering motor through a small hole, and splits the thin beam in half using a paper card. What he noticed on the wall that the light hits after it passes through is an interference pattern. Young postulates that this pattern is only achievable if light travels as a wave and produces the same pattern that you see when you disturb water into wave patterns, which he carefully sketched as part of his studies. Through this experiment, Young proved Newton wrong. Newton was a god in the UK, and in fact all over Europe. To go against his work was blasphemy. But the experiment wouldn't lie, and so it was determined that Young was in fact correct. Light behaves as a wave. Sort of. Now, I don't think I can get through all of the physicists that I'd like to cover in just one video, so I'll do this in multiple parts. The idea is to go through the history of physics and the physicists themselves in the order that you might experience it if you were to do a bachelor's program in physics. So this will be part 1, and part 2 will discuss likely atomic physics, maybe a little bit of modern physics. I don't know if we'll make it quite into quantum mechanics, but we will see. Thanks so much for watching, and tune in for part 2.